So for the recording, should I stay here or move around or like here on the side, or where is the camera pointing at? Here? I can move. Okay. All right. There are some people coming in. Give them a couple of minutes. They're rechecking everybody's badges. All right. I think we can get started. Thank you all for coming. My name is Pablo Alvarez. You might have seen me before in the panel. I lead the product management team at Denodo Technologies. And I want to talk a little bit about what it means to get Presto and try to put it into a commercial distribution. Some of the lessons learned along the way, some of the things that we are working on, some of the contributions that we are already released or that we are working on, and the reason behind those contributions in the context of customer requirements and whatnot. I'll also talk a little bit about what it means for us to adopt Presto C++, some of the tests we are done, and some of the opportunities that we see there. All right. So before I go any further, just one slide to explain a little bit what's Denodo. Denodo is the company I work for. It's a company that works in the data management space. We are known, I think, more than for anything else for the concept of data virtualization, which is at the core of our platform, of our system. The idea of virtualization is to abstract the data from its original format, so you can treat different assets coming from different places, different formats, different protocols, as if they were all homogeneous and together in the same place. And that idea of virtualization we use for data integration. We can federate in real time, we can integrate point-to-point and different things like that. We can manage that data in the sense of bringing security, building semantic models, documenting, governing, things like that, with the ultimate goal of delivering information to others. That abstraction layer is something that works like a virtual database you can connect to and delivers data to the consumers, whether through JDBC or DBC, and also different formats of APIs, like GraphQL, OData, and whatnot. The reason why I'm talking about this, as I mentioned, is because as part of our platform, we distribute Presto as a component that is focused on a few things, but mostly as the data lake execution engine on top of an object storage. But as we'll see along the way, a few other capabilities to kind of offload processing or like offload workloads or data sets from other systems. But that little blue box that I have there, the effort that went into putting that there is kind of what I want to talk about today. All right, first of all, I wanted to touch on why did we choose Presto to do that. And there's a variety of systems out there in the market that we could have chosen. We decided to go to Presto for three main reasons that I briefly outlined in the panel this morning. First, because of that strength that gives to the project the fact that Meta, Facebook, has been behind it from the beginning. That means that it works at a scale, probably at the most massive scale that you can imagine. It's battle hardened. It's something that you know it works. It has that guarantee. And I think that's important for us as a vendor to make that decision. Second, again, as I mentioned during the panel, the way the open source project works, in the way that through the Linux Foundation and the Presto Foundation guarantees certain neutrality. There is not like one vendor that has part of the software open source just as a way to kind of lure community. This is a true open source project where you know that your contributions are not going to be vetoed by others because you enter in conflict from a commercial perspective. That's also something that doesn't really work well for you to make an investment on an open source project like we're doing here. So the fact that Presto has that neutrality and is backed by both companies like IBM that are developing, but also by clients like Uber, like companies that use the software, like Intel, like a lot of different components of all of that that guarantee that like you are getting different points of view and they are all respected. That was also very important for us. And finally, the future of it. It's not a project that is dying, it's a project that with Velox and C++ is getting a brighter and brighter future. So all of that made us land into Presto and decide to go in that direction. All right, so with that decision in mind, I want to start from the beginning. We decided to go into adopting a data lake engine into our platform because we had a set of customer requirements that were coming to us that were pointing in that direction. The alternative was to tell our customers, go procure a data lake by yourself. We wanted to give them a solution. They wanted to have a more integrated solution. That's why we went there. So what were those requirements? There's kind of three different types that I want to highlight. First is customers that approach us with a requirement for a new data lake. If you attended the conference from Perkins Coie, they had that requirement. They had large data volumes. They were too slow to execute. They wanted to adopt a type of execution engine that gave them those capabilities. In this type of scenarios, I tried to list here kind of what was the expectation. Large volumes, both for storage and for processing. Integrated DLT capabilities that you can use the engine itself to create and curate data. Cost-effective and scalable. Critical. Nobody wants to have something that is too expensive, especially if it's part of a platform that you're already paying for. Compatibility with modern standards, particular Parquet, Delta, and Iceberg. I know that there is also Hoodie out there from our customer base. Hoodie hasn't been that relevant, and we haven't really made an investment in adopting Hoodie. So Parquet, Delta, and Iceberg is where we have put our biggest effort. Cloud deployment options with low effort, and I'll talk more about that later, but that's definitely one of the things that your clients want to do. They don't want to waste their time deploying something extremely hard to get up and running. And security and vulnerability-free deployments. I feel that's something that over the last 4 or 5 years, people have put like a much bigger effort on getting vulnerability-free deployments. So that, just to give you a quick run through of what came from this type of scenarios. But there is a couple of others that I also want to mention. One is people that approach you with an older Hadoop-based data lake effort that is not up to current standards in terms of speed and performance, and they want to have another layer on top that allows them to reuse certain processes that are already there. They don't want to implement everything they have, but they want to get modern speeds on that. Thankfully, you have like certain standards like Parquet that allow you to do that, high meta store, etc. But at the same time, you also get a new set of standards that are more on the legacy side to be compatible with deployments on-prem. For example, things related with Kerberos that are quite painful. I don't know if you have ever worked with Kerberos. Nobody wants to do that, but it's the reality and it's there. So this type of projects come with that additional pain that we need to support. And a third one, which is also quite relevant. This is people that also have a data lake or a lake house already in place, but for certain reasons, whether it's ownership, purpose, or cost, they want to use something else. And I think this is something that you have seen different users talking about this earlier, where you might be using Databricks for ETLs, but then you want to use Presto for execution. So there you have normally a mix of cost and a mix of capabilities. Presto is better for interactive high concurrency queries, for example. Or you might have a department paying for a data lake. They're okay if you connect to those files, but they don't want to pay for your usage because it's expensive enough. So things like that create these sort of situations where you have files, normally whether Parquet or Delta and Iceberg tables, that you need to reuse and connect to have an alternative engine on top of that. Recently, the last couple of years, we've also seen the rise of these new catalogs that are meant for data sharing, like Snowflake with Polaris, implementing the Iceberg REST catalog, or Unity and Delta sharing from Databricks, where they bring kind of an additional level of abstraction in terms of security and access control, and we need to be able to integrate with that. And there's also scenarios where the system might be completely different. Maybe you have Redshift or you have Exadata or whatever, and you need to move some data there. So it's not just connecting to existing files. You need to sync up the information. So there's also requirements that have come from that perspective, which is a different form of offloading by moving data. So these three at a high level is more or less what we have on the table that we need to be able to fulfill with a distribution of Presto. And I'll try to connect kind of like the different configuration decisions, deployment decisions, and contributions to these three use cases. All right, so let's start with those decisions. From the perspective of technical decisions first. The first thing that I decided to start with here is object storage. There's a variety of object storage options, and we have seen a lot of different things. Most of people is working these days in cloud systems. So you have S3, you have Google. Those are supported out of the box by Presto. Then you have things, especially if you're working in the Chinese market. Huawei, for example, has a compatible object storage with S3. Those work out of the box. Now, the one that does not work out of the box, and it's a little painful to configure, it's Azure. So Presto technically supports ADLS because Presto supports HDFS, and HDFS has extensions to all of these other file systems. But it's a little tricky to configure. Happy to chat with you about this if anybody has more questions about this later on. But by adding the right dependencies and the right properties and wrapping that in a way that is easy to configure, you can quite easily bring Azure object storage options to a Presto distribution. On-prem, we have also seen things like S3 compatible file systems, MinIO or Minio, I never know how to pronounce that one. Or Dell also has a file system compatible with S3. Those normally work out of the box or minor tuning options. As I mentioned earlier, this little guy here gave us a bunch of headaches. HDFS on-prem, inherited from Horton, Cloudera Awards, normally comes with Kerberos enable. And there is some things you need to keep in mind to do that. It's not super difficult, but you need to add additional configuration so the workers can access the file system and they can authenticate. So this part is relatively straightforward. In terms of data table formats, I mentioned Iceberg, Delta, and Parquet. Parquet being the kind of most widespread file format, and Iceberg and Delta, the table formats built on top of that, with additional capabilities like versioning, time travel, ACID transactions, and whatnot. As I mentioned before, we have not invested in Hoodie, although it's another possibility here that Presto provides. We have not really added any support for Hoodie in our deployments. Now, what things did we find here? So getting a little bit more into the details of contributions. For Delta, I'm not sure why, but Delta doesn't seem to be super widespread in terms of usage within the Presto community. So something that happened a few months ago is that Databricks evolved the version of Delta to 3 point something. That brought compatibility with the Delta connector within Presto. So something that we contributed recently was that upgrade of the code to be able to work, having Presto working on top of the latest version of Delta. So that's possible, I think, since 289, the latest version. It was merged quite recently. So if you're on the latest version of Presto now, you can use the latest version of Delta seamlessly. In terms of Iceberg, Iceberg works pretty well, both in Java Presto and in Presto C++. One set of capabilities that are missing right now in Presto, though, is the capabilities for upsert or merge. I don't know if you guys are familiar with the idea of merge or upsert. It's a mix of insert and update. So it's useful when you're trying to sync up like daily, like micro batching, daily updates. You just want to get the existing data and use the delta to keep that in sync rather than doing a full refresh. What it does is you get like a table with the delta and then merge the two to create the final copy. That's why it's called merge. This is a work in progress, pretty advanced, so hopefully it goes into the next release of Presto. And it opens the door to do those kind of like sync ups that I mentioned before when you are trying to move workloads to Presto from other systems. And we actually had the talk from Perkins Coie before. They are currently doing that in Databricks. This set of capabilities will open the door to do that directly in Presto, which currently is not easy to do, or is not possible at all. The other area that I also mentioned is the compatibility with these data sharing catalogs. There is Snowflake pushing Polaris. Polaris is an implementation of Iceberg REST catalog, but with some peculiarities. And then there is Unity that is also quite relevant because Unity can work together with delta sharing. So you can have people from like the Databricks universe sharing files with you, tables with you through delta sharing. You plug those into Unity, and then you can consume those through Presto. So for those reasons, these two areas are quite relevant. There are some limitations on what Presto can do today. These are, I think actually one of these was merged yesterday, thank you. But yeah, those are three areas where we have been contributing to be able to have this type of scenarios working with Presto and in extension with our platform. They're all relatively straightforward and should be ready, hopefully, for the next version of Presto. All right, moving on. The next area where we had to make decisions, it's in terms of deployment options. As I mentioned, we wanted to offer a set of deployment capabilities that made it easy for our clients to deploy with a couple of clicks or a couple of configuration options. So for that, we chose Kubernetes and Helm charts. Main reason is that Kubernetes and Helm are compatible with a variety of platforms. You can do it on-prem, you can do it in Azure, in Google, in Amazon, and you can do it with OpenShift with almost no changes. With OpenShift, there is a few minor things that you need to be aware of, but in general, there is almost no changes, and you have a set of files and scripts that allow you to deploy seamlessly in almost any platform. Unfortunately, we started this work about the same time that somebody started working on that to contribute to the Presto Foundation. I think a guy named Dimitri, if I remember correctly. Thank you, Dimitri. But we did the work in parallel, so a little bit of an unfortunate situation. On the bright side, it gave us pretty good expertise on how all of that worked. And we, as Tim mentioned, we have contributed very recently the updated Helm chart for deploying Presto C++ with Kubernetes. So that now it's an option available to everybody that makes that quite easy. In terms of the deployment, another thing I want to mention is that we include in our deployment coordinator, workers, of course all the options for scalability and whatnot, but also the Hive Metastore and the database for the Hive Metastore. Those are optional. Some people already have a Hive Metastore, or you might want to connect to Glue or something different. But if you don't, if you're starting from scratch, this means that you have one-click full deployment, fully enclosed, that you can start using immediately. And as an additional piece, if you're in EKS or AKS, this is Azure or Amazon, we also provide the CloudFormation and the ARM templates that deal more with the periphery of the Presto deployment. This is networks, subnetworks, load balancers, and things like that. So simplify the deployment even more. The goal is to have like one-click deployment and easy configuration of the options that can be parameterized. And I think we got there. All right. Another thing that you find along the way, especially when you start working with, most of our deployments have been in unfortunately, healthcare and finance. And I say unfortunately because those are two sectors that are very highly regulated. So everything that you think that you have solved, then you get there, and oh, I have this regulation that is unique to my country and my region and my sector, and then things don't work. So there's been a lot of situations like that. So I just wanted to share here a few things that we have seen along the way. OpenShift, as I mentioned, allows you to deploy a little bit more controlled deployments that Kubernetes in the EKS, AKS flavors. You have the advantage that whatever runs in OpenShift runs in the other platforms, but there's a few additional restrictions that you need to be careful with. Just mentioned there are a couple. You cannot run things as root. You can in AKS, you cannot in OpenShift, and you can only have one service per container. So if you're trying to create kind of multi-service containers, things like that, they don't work. And generally, fairly straightforward. Those are just, you can just Google how to make your Helm charts compatible with OpenShift, and these are things that come pretty easily. Things that are a little bit trickier, credential management. There is, in a deployment, normally a number of credentials. Credentials for accessing the file system or the object storage that need to be managed somehow. And depending where you're deploying, there might be other credentials to manage. If you're in finance or in healthcare, credentials definitely cannot be in plain text. So forget about having like an ID and secret in a configuration file. What are the alternatives? Well, if you're using Presto, there's these options here, Hive S3, AWS Access Key, things like that. Those are some configuration parameters for Presto, but there you have to use plain text. So that doesn't work in this type of deployments. There's other alternatives like pod identities, instance profiles, and whatnot that work well. They don't require credentials, but are dependent on your specific platform. So it means like more complexity in your Helm charts and whatnot, but can be done. Another alternative is you have the Hadoop credentials key store, where you can manage credentials as well. This is something that can be also a little tricky to get to work. I don't know if you guys are familiar with that. There is some regulations in the US about encryption and what you can distribute, or you can distribute outside the US and whatnot. There is some libraries, the Bouncy Castle, probably the most popular, that allow you to deal with that. But it's not like something that might work for everybody, especially if you're in environments that are under FIPS compliance. I honestly don't remember what FIPS stands for, but something about extra security that makes your life a little harder. So this section here, I tried to summarize it, but it's been a source of headaches. It's pretty much when you're in these highly regulated environments, every client will come with something that doesn't work for them, and you need to find whether new options or one of the areas that has given us more headaches. What we are looking at right now, and kind of seems like the way to go, is using credential vaults. In cloud, both in AWS and Azure, you have credential vaults. Out of the box, you can put things there, and then you can work with instant profiles to access the vault and things like that. So seems to be the option that is the least friction. But in general, this is an area where you'll find, if you try to do this yourselves, I see some heads nodding here, the most pain. And as I mentioned before, Kerberos, if you have Kerberos because you're working on on-prem deployment, that's always tricky. As a piece of advice, if you already have a Hive meta store that is working, inherited from a Cloudera, from a Hortonworks, just connect to that because it's working. And you don't have to reinvent the wheel twice because it's going to take you days, if not weeks, to get that working when you can just point to that. And there's going to be a lot of debugging. We have a team that is fully focused on working with Kerberos. I don't wish to have their life. All right, moving on. Vulnerability management. This is something that maybe working open source doesn't come up that often. When you're on the commercial side, this is also a big source of headaches, especially if you have customers, again, healthcare, finance, or public sector. Because they have very strict guidelines, and I think in the last couple of years, even stricter on vulnerabilities. They cannot have anything that is critical or very, very high restrictions on high vulnerabilities. Sorry for the abuse of the word high. But this creates, again, a lot of friction with the clients to have these deployments complying with all of this. In some cases, things are as easy as just going to the library that has been flagged as having a vulnerability, looking at well, if you use NIST, it's the National Database of Vulnerabilities. They normally tell you the version that has that already fixed. You update the version and things work. That's the ideal situation. Very often that doesn't work. If you guys have packaged software yourselves, you'll know that sometimes there is shaded classes or shaded packages. There is ways to get kind of third-party libraries embedded into yours, changing the name of the packages so there is no package conflict. The scanners will pick those up and will raise those as a vulnerability, and you cannot just change the library. You need to kind of create your own version of the library, things like that. Jackson is a library that, and Wava is used widespread across different packages in Presto. So those are not super difficult, but they're very time-consuming to address, especially with the client knocking on your door, like I need this fixed by tomorrow, or I need to shut off the system. We have done several contributions here. IBM has been quite active lately on this as well, and definitely more to come. We have a team doing this on a regular cadence. Something that I want to mention to the community, I think this is something that doesn't have a lot of traction in Presto as an open source community because the pain is harder to feel from other types of deployments. But I think it's critical to get the community involved. There is a work group that hasn't been getting a lot of traction because this is a boring topic for a developer. But without community involvement, it's very hard to manage this. And let me explain why. We have our set of deployments. We make sure that we package, we validate this, we scan this, and it works. But sometimes that thing that we fix is using a variety of other third-party connectors that have their own dependencies. They have their own shaded packages. And it's very hard not to break everything. And it's very hard to make sure that what you check within your commercialized version doesn't impact other peripheral projects, especially connectors, that are part of the Presto distribution. So going from your commercial version to open source Presto in that direction, it's quite difficult. So that's an area where I think there is opportunity for better work in the future, especially with that working group that we really want to have people showing up. All right. Performance, how am I doing on time? Oh, well, okay. Performance tuning. Just want to share a few things that are that have been quite important for us. So these are properties that you can enable in your Presto clusters. And these are 4 that we have seen are quite relevant in terms of improving performance. So I wanted to share that with everybody here. Dynamic filtering and push-down filters improve the efficiency of table scans. Vectorized readings improve the performance of how data is read. And quick stats is a recent contribution from IBM that allows you to use the cost-based optimizer to work better even when you don't have the full set of stats available. So there is less bad plans being generated by the Presto optimizer. Some of these, like you see here, like the gain factor in the batch rate optimization can be quite significant. So this, I think, by default, they're all disabled in the official Presto images. Worth turning them on because they improve things quite a lot. Moving into C++, and this is kind of like getting towards the end of my session here. Just want to kind of reiterate what everybody has been seeing and talking about the last few sessions here. Like C++ brings better resource utilization, better efficiency, better memory consumption. So overall, you get your queries running faster. But not just that, and more in just a second. And with the benefit that it's almost a drop-in replacement. You can, if you did the workshop yesterday, I don't recognize any faces, but well, we had a workshop where we were doing this, literally get a Presto Java cluster, changing a couple of things in the configuration file, and you have a Presto C++ working. Same queries. There's some minor things there, but in general, it's a drop-in replacement. So we're very excited to get into this. As I mentioned, we've already been working on Helm charts. Those are already available, and it's something we're internally working to package in 2025. Putting all these things together, fine-tuning configuration properties, and looking into C++. Just wanted to show you a little bit kind of the progression. The red column is Presto vanilla, as it is if you get it from the website with the Helm chart that is open source. With those optimized options, you get quite a bump there in performance, and with C++, significantly better. These are using TPCDS scale factor 1000 datasets. The queries are custom queries that we build to test specific things, but you can get an idea of the improvements. Now, I'm sure everybody wants to see more charts, and if not, you're going to see them anyway. Something critical that I think comes with Presto C++, that efficiency shows when you're running one query, and you'll see queries sometimes 2-3 times faster, at the very least like 30-40% faster. But when you get concurrency, all of that adds up, and you get like really, really impressive numbers. And if you combine that with a history-based optimizer, even better. So 2 things to highlight in this chart. The first chart, you see this is the number of query 1, query 2. This is the level of concurrency, 1, 5, 10, 15. This is a little exaggerated, I have to say. We created a cluster that we know with 15 queries is kind of at capacity to show the effects. But what you see there is the queries in Presto Java, especially when you hit that threshold of the cluster is at capacity and they're struggling. With C++, it flies because it's much more efficient in using memory and using CPU. And this means that you can get huge potential impact on hardware cost. What you see here is the same queries, but here I'm comparing Presto with 20 workers with Presto C++ with 2 workers. So you see that, I mean, it's not that they're fully equivalent, but they're not out of whack. They're in the same order of magnitude, and the cost is 10 times lower in terms of hardware. So that is where I really see this being a game changer. The idea of C++ reducing your hardware cost or allowing you with the same hardware to increase your capacity 3, 4, 5 times. Huge cost reduction coming up. I just want to close with this last figure. How does this compare to Trino? Trino, well, one of the things that C++ is able to do is to leverage vectorized processing better in C++, directly working with the CPU. And the latest version of Trino, Trino 451, I think they might be in 452 or 53, this is from a few months ago, has implemented vectorized processing in Java. Latest versions of Java, Java 17 and further, I believe, have vectorized processing in the JVM. So you can get some of that with Java workers, but how far can that get you? And this is the same idea of the 1, 5, 10, 15. You can see that in general, Prestissimo with 1 is a little faster, but you won't see like a huge difference. But when you get into concurrency, that's where that shows, and you see like the Prestissimo or Presto C++ is the red bar. It still gets you to 2-3 times faster performance than Trino in those levels of concurrency. Again, if you add to that the history-based optimizer, I think the difference can be quite significant. So that's it. Just to wrap up my session here, touching on the key 4 topics. Infrastructure, there's a lot of technologies like Helm charts, CloudFormation scripts and whatnot that make your life really easy, and you can achieve those one-click deployments. Hybrid is still there. You have on-prem, you have cloud, and we need to deal with both, and probably will for quite a while. Security, it's very important, especially for a commercial vendor, and there is a lot that we're doing, and there is way more to do, especially on that vulnerability management. And in terms of performance, I just see good things coming up, and the future is bright. So that's all. Thank you very much. Sorry for going a little bit over time, and hope you enjoyed the session. So thank you all.